So for our final example here, we're going to be looking at C-section rates. In the U.S., cesarean sections are of about a 31.7% chance of happening to a woman when she goes in to give birth. Now, this percentage is actually a great deal higher than the naturally occurring rate that the World Health Organization recognizes and says that we should aim for. And so the reasons behind that are really super interesting and something to look into. But for our problem, we're actually going to be asking this very specific question, and that is, if a clinic has 10 women give birth, what are the chances that the majority of them actually end up having C-sections? Now, once again, we have to reaffirm to ourselves that this is in fact a binomial, and I can tell it is because I'm assuming one woman has nothing to do with the next woman's birthing practice. And I'm also assuming that either she has a C-section or she doesn't. So, two different options, independent, I can do a binomial. Now, this is a little bit different than the previous prompt because I'm asking what are the chances that the majority of them have C-sections. And so if we're starting with 10 women, and I want the majority to have C-sections, well, a majority would be over 50%, right? So that is out of 10, well, maybe 6 of them, or 7 of them, or 8 of them, or 9 of them, or even 10 of them. So all of these are cases where the majority of them would be having a C-section. What this means is that in order to calculate this probability, I'm going to have to do it for 6, 7, 8, 9, and 10. Which means that our single problem just turned into 5 separate problems. So what we'll do is we'll go ahead and we'll calculate the probability that 6 of them have C-sections. We'll calculate the probability that 7 of them do. We'll calculate the probability that 8 of them do. We'll calculate the probability that 9 of them do. And then we'll calculate the probability that 10 of them do. And then once we get all these, since we want the majority, we'll go ahead and we'll add each of these up. Either 6 of them, or 7, or 8, or 9, or 10. So, in this example, we're going to go ahead and we're going to do one of them, and then if you'd like to, you can calculate the rest of them, and then I'll go ahead and add them up and give us the total. So, to begin, we'll go ahead and look at the probability that we have exactly 6 women give birth via C-section. So, for this one, we'll go ahead and list out X, N, and P. In this case, I have a total of 10 women. 6 of them should be having a C-section, and the probability someone has a C-section is 0.317. So when I go to plug into my formula then, I'll have the probability that I have 6 of them having a C-section is equal to 10 choose 6 times 0.317 to the 6th times 1 minus 0.317 to the 10 minus 6. Simplifying this before I plug it in, then I'd have 10, choosing a combination of 6, times 0.317 to the 6th, times, and 1 minus 0.317 should give me 0.683 to the 4th. And to be clear once again, this tells me how many different combinations I have of that. This says the percentage of people having a C-section is 31.7%. There's 6 of them doing that. And the percentage of people not having a C-section is 68.3%, and there's 4 of them doing that. So plugging that in then and getting 4 decimal places, we get a value then of 0.0464. So there's a 4.64% chance that if I have 10 ladies, exactly 6 of them is going to have a C-section. Now we'd go ahead and we'd repeat that process for this one here. We'd repeat it again for this one here, repeat it for this one here, and then finally for this one here. Each time, notice we're going to change what X is, but N and P won't change. After we get all 5 of this, the next thing we'll do is add it together. I do want to point out that as you go across these probabilities, the numbers are going to get smaller and smaller and smaller. So for this one, we're probably going to get something right around 0.0123. For this one, 0.0021. Here, 0.0002. And when we plug in x equals 10, we're going to get a probability so small that when you round it to 4 decimal places, you're actually just going to get 0. It's important to realize that the probability isn't 0 itself, it's just so tiny that we round it that way. Then when we go ahead and we add all these values together, we're going to find something of 0.061. What this tells us is there's about a 6.1% chance that the majority of these women would have C-sections. in this problem, what we've done is we've practiced finding binomial probabilities, but we've also looked at this case where we're asking the majority. Anytime we want to know the majority, or at least, what we'll do is we'll find the individual ones and then go ahead and add them all up.